When air flows around the wing, it creates spinning pockets of air called vortices. At the leading edge, they are called leading edge vortices, or LEVs. LEVs mostly affect small-scale flight, like insects, birds, and micro-air vehicles, which are air vehicles that are less than 1 meter in length and travel at speeds normally between 8 to 15 meters per second. LEVs can generate a lot of lift. However, they develop very quickly, with most of their effects waning after about 3 chord lengths of travel. This results in increased turbulence and less lift to be generated for the micro-air vehicles. Through research, we can find ways to increase the amount of lift generated by the micro-air vehicles by finding other ways to harness the power of the LEV. We can also gain insight into how to manage turbulence in this situation and others as well. My research was conducted computationally, and I sought to find the best wing shapes to allow the LEV to be attached for the longest. This is an example of what my simulation space looked like. The wing is attached at one end, similarly to how it is attached on aircrafts, and air is free to flow around all other sides of the wing. This is a subset of my data. We know that when the lift is increasing, the LEV is developing, and after the lift starts decreasing, the LEV has been shed. From this, we can analyze the data by finding out these peaks and troughs, and from this picture right here, we see that the gray curve has the largest amount of time where the LEV is attached. This actually corresponds to this yellow airfoil over here. In the future, I hope to also consider different wing motions, as well as non-conventional wing shapes, to see if it has an effect on how long the leading edge vortex remains attached to the wing. I would like to thank the Burrell's Wellcome Fund, the NCSSM Foundation, the NCSSM Science Department, as well as the NCSSM Science Foundation for funding this research program over the summer. I'd also like to thank my mentors. I'd like to thank Dr. Bennett for guiding me through the research process, Dr. Slinker for helping guide me through my project over the summer, as well as Mr. Gottwals for helping me get started and with supercomputing. Thank you!